Firefighters risk their lives daily to protect our communities from fires and emergencies, facing health hazards such as heat exhaustion and overexertion. Currently, there's no standardized wearable equipment to monitor health and provide alerts on scene. We offer a non-invasive biometric monitoring system to address this critical gap, potentially saving lives and preventing injuries. Hi, my name is JC, and our senior design team is from the Biomedical Engineering Department here at UTA, and we are excited to share this project with you. Our goal is to provide real-time monitoring of the vital signs of firefighters during rescue operations, allowing for early detection of any physical distress, thereby preventing potential injuries and fatalities. We believe that our project has the potential to make a significant impact in the field of firefighting and enhance the safety of our firefighters.
Firefighting is a dangerous and physically demanding profession. However, the job comes with many occupational hazards, including heat exhaustion and overexertion. A serious problem in the field of firefighting is that firefighters will hide symptoms of illness or injury caused by heat exhaustion or overexertion and will continue to push themselves to the limits. Attempts are made to ensure firefighters aren't going overboard by requiring rehabilitation periods after 40 minutes of strenuous work. Yet, there is still an average of 2 hospitalizations per month in the Arlington Fire Department alone. To address this need emphasized by the Arlington Fire Department, we developed a non-invasive biometric monitoring system that can provide insight into the health of firefighters throughout the department by measuring heart rate and estimating core body temperature. Our device could provide critical health alerts to help prevent accidents and injuries while on the job and dismantle the culture of hiding symptoms.
Our solution uses temperature sensors, PPG sensors for heart rate, microcontrollers, and LEDs for estimation of core body temperature and to process biometric data in real time. The system triggers alerts when predetermined thresholds are met, providing a dual monitoring system with LED alerting. The system is designed to integrate with firefighter gear and protocol, ensuring that it doesn't interfere with the firefighter's work. We've carefully balanced accuracy and practicality to create a device that meets the unique needs of firefighters. During our development process, we created small breadboard prototypes to test LED alerting, temperature, and heart rate measurement before integrating them into the main device. We used C++ to develop a microcontroller for real-time biometric data processing. Physical dummy prototypes were developed to evaluate the ergonomics of the wearable device and determine where to integrate our system with the gear. We also used SolidWorks and 3D printing to create proof-of-concept prototype housings for testing the system's ergonomics and ideal device location during wear. The system interfaces with a thermistor for temperature and a PPG sensor for heart rate. For our heart rate detection, we gathered 400 samples per second of data. We used a 32-sample low-pass filter as well as a finite impulse response filter for noise removal to smooth our data. We used a moving average threshold filter to detect threshold crossings and identify the maximum peaks to obtain a heart rate. These filtering techniques also help deal with motion artifacts by smoothing out fluctuations in data caused during exercise or movement.
Together, the heart rate and temperature provides the needed metrics for our minimum sensor input model for our core body temperature estimation.
The prototype's LED alert system has 3 LEDs, green, yellow, and red, that flash when thresholds are met. The thresholds are based on research on critical heart rate and core body temperature levels during exercise.
Once we got a working prototype, we conducted a series of comparative studies with an eye health fever thermometer that estimates core body temperature and an ECG machine to record the heart rate in order to ensure that our device was performing properly and collecting accurate data. We performed all of the following procedures while the device was located on the subject's wrist, followed by the forehead. The first study we performed was to establish a baseline of the heart rate and core body temperature estimation. The subjects sat in a seated upright position and were asked to relax for 3 minutes. The data we collected is shown here. All data that is shown throughout this video has been normalized to the standardized measurement equipment. For example, the heart rate data is normalized to the data from the ECG, and the core body temperature is normalized to the data from the eye health thermometer.
In the future, we aim to develop a wireless system with a central control unit and cloud component. This will enable commanding officers to access real-time health data on a tablet for all firefighters. They can adjust their strategies based on these metrics. In conclusion, our non-invasive biometric monitoring system could be a game changer for firefighter safety by addressing the unique occupational hazards firefighters face by providing critical health monitoring and alerting. We are grateful for the mentorship and support of the Arlington Fire Department throughout this project. With this project, we aim to prevent injury and improve health and safety conditions for firefighters, ensuring that they can continue to do their jobs safely and effectively while bravely serving our communities.